Okay, so we have some binomials written as a product in a weird way. We're used to seeing two binomials next to each other and we just double distribute them. However, we have this looks different, but it really is the same. This says x plus 3 squared. What that really means is x plus 3 times x plus 3. And if I double distribute that, I get x squared plus 3x plus another 3x plus 9. If I simplify that, I get x squared plus 6x plus 9. Okay, I'm going to skip down to this bottom one, 2x plus 5. 2x plus 5. So 2x times 2x is 4x squared. 2x times 5 is plus 10x. 5 times 2x is another 10x. And 5 times 5 is 25. Combine my like terms and I get 4x squared plus 20x plus 25. And there's nothing wrong with doing these problems in the way that I've just shown you. Nothing wrong with that. However, my goal for today would be for you to be able to multiply those out with a little bit of a shortcut. What I want you to notice is that the first term comes from the first term of the binomial squared. So x went to x squared, 2x went to 4x squared. So the first term in your trinomial, your a term, my mouse got kicked while I was writing here. My first term, which is my ax squared term, is where I take and I square the first term of the binomial. And I'm going to skip to the last term for a second. Okay, the 9 comes from squaring the 3, and the 25 comes from squaring the 5. So the last term, or the C term, comes from squaring the second term of the binomial. Now the middle term is kind of a yellow and blue makes green kind of situation. To get the middle term, do you see how I multiplied 3 times x and another 3 times x? So I have 2 3x's. So that's kind of the same as multiplying the 3 times the x within itself, within the binomial, and then doubling it. So 3x and double it. 2x times 5 is 10x, double it, 20x. Okay, so I multiply the terms of the binomial and double it. So let's practice that. So if I have x plus 8 squared, okay, my ax squared term is going to be just take the first term of the binomial and square it. My last term, my c term, is going to be the second term and square it. And my middle term is where I'm going to take these two and multiply them together, 8x, and double it for plus 16x. Let me do that again. So if I have 3x plus, I don't know, 9 squared. Okay, 3x squared would be 9x squared. 9 squared is 81. And then my middle term, my bx term, is 3x times 9 is 27x. And then double it for 54x. And if you're not sure, put both into your y equals, make sure they overlap. Minuses work exactly the same way. Okay? They're not any different. So I'm not going to go through this whole screen with you again. I will do this problem and this problem just demonstrating. So x minus 4 squared. Okay, so x squared. Now, minus 4. If I square minus 4, that's going to be a plus 16. Anything you're squaring that's minus ends up being plus. A minus 4 times a minus 4 is a plus 16. Okay, and then my middle term is going to be x times minus 4, so minus 4x, and double it, minus 8x. Five x minus 7 squared. Okay, square it, square it. Remember, negative 7 times negative 7 is positive 49. And then in the middle, multiply negative 35x and double it, minus 70x. Okay? Then, and probably the easiest scenario, is when it almost looks identical, except the signs are different. An x minus 4 and x plus 4. It's still an x and a 4 and a 4, just opposite signs. So if I double distribute this out, I get x squared, a plus 4x, but then I turn around and get a minus 4x. Negative 4 times positive 4 is minus 16. So what's going to happen now when I combine like terms is that those x's cancel out, and I get x squared minus 16. Here again, I want to do just the first one and the last one because the middle one is just like the first one. Okay, so 3x minus 4 and 3x plus 4. If I double distribute that out, I get 9x squared. I get plus 12x, minus 12x, and minus 16. But those 12x's cancel. So I get 9x squared and minus 16. So these are actually easier to do. And I would say difference of perfect squares, doing this sort of double distribute and particularly factoring, this comes up a lot more. So the first term, again, square the first term of each binomial. Middle term cancels. And the last term is the negative square, or subtract the square of the second term. Of the binomial. In other words, if I was going to do x minus 6 and x plus 6, I would just say, okay, x times x is x squared, And minus 6 times plus 6 is minus 36. There would be no middle term, no b term. If I was to do 5x plus 6 and 5x minus 6, I would square those, so 25x squared, a minus sign, and 6 times 6 is 36. That's it, because the middle terms would cancel each other out. Now, here's where this becomes uber important. When you factor, look, there's nothing stopping you from factoring like normal. Just like there's nothing stopping you, you can double distribute out and write out all the special cases. There's no rule that says you must use these shortcuts. It's just that in special cases, the shortcut makes life easier, and later on in chapter 12 we'll be doing something called complete the square, in which this shortcut will become useful to you. Okay? Not necessary, but useful. So if you're looking for something to be a perfect, a special case, you're looking for the A and the C terms to be perfect squares, and plus for being the one kind of special case where it's the same binomial squared. One thing you're going to have to look for, though, is you might have to factor out a common factor in the beginning to make that happen. Okay, so we got some examples and some non-examples. So in our first example, this has an imaginary 1 in front of it. 1 is a perfect square, x squared is a perfect square. So our A term is a perfect square, and our C is a perfect square, and it's being added. So that tells me that I can write x and x. Plus means signs are the same. Minus means they're both minus. 5 and 5. And what I'm just paying attention to is if I do this, okay, will I get 10 in the middle? In other words, 5 times 1 is 5, double it to 10, which I do. And then as a final answer, you want to write it as x minus 5 squared. Okay, so the second example is, again, what I'm talking about with Ms. Anders. 2m squared is not a perfect square, so I don't think this counts. Well, it does if you factor a 2 out. Okay, so if I factor out a 2, I get m squared. Factor out a 2, I get plus 14x. Factor out a 2, and I get plus 49. So now I do have a situation where I've got a perfect square in the parentheses for A and for C. So m plus 7, m plus 7, 2m plus 7 squared. Just don't forget about the 2. You have to carry it down. Don't forget that leading coefficient. And then our last example has a leading coefficient of 4, but I don't want to factor this. First of all, I can't factor it out, but I don't want to anyway because 4 is a perfect square. 2x and 2x plus 5 plus 5. So 2 times 5 is 10, double it, 20, so that worked. Here's some non-examples. This may at first look like it's a special case because I've got a perfect square for my A term and a perfect square for my C term. However, the 36 is being subtracted, so this isn't going to work for special cases. Okay, then I would just try regular factoring. Okay, but it's not going to be a special case. The only way I would get a minus here is if the signs were different. And special case would mean they're both 6's. But if I make those both 6's, I won't get 12x as a middle term because a plus 6x and a minus 6x would cancel each other out. So that didn't work. So you could try regular factoring. plus, minus. Now, is there anything that multiplies to 36 and subtracts to 12? So 36, let's see, 1 times 36, nope. 2 times 18, nope. 3 times 12, nope. Now, we've gone from 18 minus 2 is 16, and 12 minus 3 is 9. So even if we keep listing the factors, we're not going to find anything that subtracts to 12. So not only is this not a special case, this is not factorable at all. Okay? Our second non-example. All right, looks like it's going to work. It looks better than the other one. Let's see, I've got a plus sign here, so minus 6 and minus 6. Oh, but minus 6 and minus 6 make a minus 12, and I got minus 13. Shucks. So it's not a special case. However, 9 and 4 work. 9 times 4 is 36, and negative 9, negative 4 make negative 13. So this is factorable, but it's not a special case. Factorable, not a special case. Okay, our last one. Perfect square. 81's a perfect square. Sign's the same. Must add up to negative 10, so 2 minuses. Sadly, minus 18x and minus 18x, they do not make a minus 10. So I can't take 9 times 2 is 18, negative 18, and double it and then get negative 10 somehow. Nope, this is not a special case. Not special. It is in fact not factorable. Okay? Okay, difference of two perfect squares. So how do you factor something when it does not have a b term at all? Well, I would be looking for difference of two perfect squares, and they use this on the Regents a ton. What you're looking for again is an a term and a c term. The b term will be missing. The a term and the c term will be subtracted, or you factor out a negative sign to make that happen. Okay, and you've got a perfect square and a perfect square. X plus 7, x minus 7. Okay, my next example down here, 5x squared minus 45. Neither of those are perfect squares, but I can factor a 5 out and get x squared minus 9. Well, those are perfect squares in the parentheses, so I'll carry my 5 down. X plus 3, x minus 3. So whenever you see an a term subtracting a c term with no b term, look for that possibility. Look for the possibility that it's going to be difference of perfect squares. My last example here, I've got 36x squared minus 100. Those are both perfect squares. 6x minus 10, 6x plus 10. So you're just using square roots. Okay, not examples. Things that look like they will work, but they don't. First of all, x squared plus 16. X squared, that's a perfect square. 16, perfect square. However, it's a plus sign. Well, a lot of students are still like, no, 4 will work, Mrs. Andrews. Just put plus 4 in each one. Okay, well, if I double distribute that out, I do get an x squared at the beginning. I do get a plus 16x, or plus 16 at the end. But I also get a plus 4x and a plus 4x in the middle. And they don't cancel each other out because they're both the same sign. So that will become plus 8x. And our original problem did not have a plus 8x in it. So that did not work. Well, Miss Andrews, then just switch them to minuses. Okay, let's look at that. Minus 4 and minus 4. I'll still get a plus 16. Middle terms will be minus 4x and minus 4x. Well, again, they don't cancel each other out if they're both the same sign. So that does not work. This is a non-example. So not only is this not a special case, but it is not factorable. Second example. Oh gosh, this looks like it's going to work because 64 is a perfect square. Oh, but 2 isn't. Okay, well, Miss Sanders, you taught us to factor out something like a 2 if we could, and we can. So x squared take away 64 divided by 2 would be 32. Oh, our 64 that was a perfect square became a 32, and that's not a perfect square. So this is also not a special case. And as far as factoring goes, that's as factored as we get. Okay? So good luck on your homework. Thanks, and see you next time.